right, today we're going to be talking about notes 2.06. So for 2.06, again, I want you to do your warm-up on your own. That's why it's a warm-up. It's getting your brain moving, okay? Remember, you are going to put your notes inside of your Algebra 1 folder that you shared with me. I will be putting grades in for those this week. Make sure you get that done so that way you do not receive a 0. All right, now, Delore the robot. Now, this is just to help you remember that your domain is left to right, DLR, and your range is bottom to top, RBT, Delore the robot. So if you ever are thinking to yourself, oh, I can't remember, domain is what was it? Think Delore the robot, or Dolor, however you want to say its name. And domain is left to right, range is bottom to top. Okay? Now, on notes 2.06, we're actually going to be talking about finding the domain and range for a quadratic function. Okay? We haven't really looked at this, but I'm telling you, you're going to love it. I think it's easy peasy, lemon parcheesi. So, a quadratic function is graphed on the grid. What is the domain and range of the function? Well, take a look at this graph right here. This is different, right? Because now we've got these two arrows here. It takes this big curve. What I want you to pay attention to is look at these arrows. Typically, when you see arrows on a line, what does that mean? It's going to go on forever and ever, right? It's never going to stop because it's arrows. It's going to keep going. So the great thing about this quadratic function is that the domain has to be all real numbers from infinity, sorry, my infinity symbol is a little wonky, to infinity, because it's never going to stop. So it's negative infinity to infinity, all the way from the left to all the way to the right. It's going to be the same thing on that next one, because those arrows right there, your domain is going to be all the way to the left, all the way to the right. Now, range is a little bit trickier. Now, we've already taken care of the domain, in which we know is the x values. Somebody remind me, what is the range? It's going to be your y values. So this one's going to be a little bit different. It's not going to be infinity to infinity, right? Because, where are we? I can see right here that we are at 4. And then it goes all the way down, right? It's going to go down, 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 never going to stop, okay? Because it's going downwards, okay? It's going all the way down. No sign of stopping. Your range is going to be from negative infinity to 4. Okay? Does that make sense? So even though your domain is negative infinity to infinity because of those arrows, the range actually does have a point where it stops. Okay, I want you to try example 2 on your own. Think about how we did example 1 and try example 2 on your own. Alright, let's look at the back page here. Example 3. Okay? Now, for this one, for example 3, you are going to tell me the domain and the range, which again, pay attention to these little arrows here, right? That should tell you exactly what your domain is. Okay, now your range, you're paying attention to where that point is on that parabola. So, if it's at negative 2, that means your range is going to be negative 2 to infinity. Because it's going to go up and up and up and up and up. No sign of stopping. Okay, now when it says verbal description, what you're going to think of is if we scroll down at the bottom here, kind of look at this one. It says all real numbers, blank and blank and blank and blank. Blank, 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 blank. So kind of the same thing. Well, if my domain is all real numbers, infinity to infinity, okay, negative infinity to infinity, I would say it is all real numbers. Now, it's up to you. I want you to tell me, how would I give a verbal description for the range? I want you to tell me your best way to say that. How would I say the verbal description for the range on this example here? All right, let's look at example 4. On example 4, notice this time there are no arrows. There's these circles, these points here. That changes things. So it is all real numbers, but there actually is a restriction now. This little circle dot here, oh goodness. Oh boy, it erased everything, but that's okay. This circle right here, if I look at that, it's at 4. Okay? For my y. But what is it asking for? It's asking for the domain. So right now, I need to look at the domain, and that is going to be my x values. So let's see where it's at on the x value. It's at -3. So it's going to be all real numbers. Remember, we're looking at the x values, sorry. Looking at the x values. It's going to be all real numbers, but it's going to start with -3. But here's the thing. The way your circle is matters. Notice how this circle is not filled in, but this circle is filled in. Okay? So what you're going to do is, if it's not filled in, it can't be equal to that number. But if it's filled in, it could be equal to that number. Does that make sense? So if you see an empty circle, we can't say equal to. But if you see a full circle, it could be equal to. So all real numbers. Now, if I'm going from here to here, left to right, like Delore the robot told me, greater than -3, and you circle it. And now we're here. Well, if I'm going this way, I'm not going past this 3 right here, so it can't be greater than. It could be less than, and remember, if it's filled in, it's got to be less than or equal to 3. Okay? All right. You are going to work on those problems on your own. Make sure you put these in your folder, and I will see you next week.